everyone, welcome to the online tutorial series of computer network subject. In this video, I will explain in brief how the exactly IP addressing is working in our network layer. So let's start with our today's topic, IP addressing. So in this video, I will explain what are the basics of IP addressing and mainly two types of addressing, that is your classful addressing and classless addressing. With the help of example, we will understand how the exactly network is assigned particular IP address. So let's start with our introduction section. So what is IP address? So IP addresses are useful to identifying a specific host or device in our networks. If in a network we have number of devices, then how can we identify that particular device? For that we are assigning one number. That number is uniquely identify that device in a network. That number is known as a IP address. So IP address is having 32 bits number that is divided into the 4 octets. Okay, for example 172.168.254 and 1. So this is my decimal representation of my IP address. The same as we can represent this number into the binary. So when we are talking about these octets are divided into the basic two parts. That parts are network ID and host ID. So combination of both network ID and host ID is generating a IP address. So now understand what is network ID, what is host ID. So when your device is assigned to any network, then that network having some identity. That identity is different from other network. So that is your network ID. In a network, single network, you have number of devices. So that number of devices are unique from each other for identification. So that unique identification is known as a host ID. So if we are assigned any IP address to device, we are uniquely identify the host and the network from that which is belongs. So this is the very basic concept. How can we assign any IP address to our device? Now we are moving to the first IP addressing techniques, that is classful addressing. So when we are talking about classful addressing, we have to understand 5 different classes. Our IP addresses range is divided into the 5 different classes. That comes from class A, class B, class C, class D and class E. So what are the different classes? Class A, B, C, D and E. So when we are talking about class A, B, C, D, E, they are dividing that range. Suppose if you are talking about total number of IP addresses, then it is the power of 2 raised to n. So here IPv4 contains 32 bit of address. So total number of IP address is 2 raised to 32. So our IP address is divided into 2 parts, network ID and host ID. So how many bits are representing network address and how many bits are representing host address? For that we are classifying our particular IP addresses into these 5 ranges. So let's understand different classes first. So when we are talking about class A, so in class A, first 8 bits 0 to 7, first 8 bits are assigned to our specific network and remaining 24 bits from 8 to 32 that are assigned to our host bits. So if I want to create number of networks, so how many networks I can use using class A? Then it is 2 raised to n. And if I want to create number of hosts using class A, then it is 2 raised to 24. So 2 raised to 24 is very large number. Suppose I have a small organization and I need some IP addresses. Should I take class A? No, because 2 raised to 24 network host I can create. That is a very large number. Suppose I need only 100 addresses, though others are wasted. So should I change that class A to class B or class C or class D? That is the exactly classification of these classes. Okay, so now understand class B. So if I am talking about class B, then first 16 bits are for network identification, that is network ID, and remaining 16 bits are used for host ID. So in class B, we can use 2⁻16 numbers for host as well as network. Now we are moving to the class C IP addresses. So class C IP addresses having first 24 bits for network identification and remaining 8 bits for our host ID. And class D and class E are used for different purposes. Class D used for multicasting address range and class E is used for reserved for future purpose. So how can, now what is the next question? If I am seeing any IP address and if I am saying it is belonging to class full addressing, so how can I know it is belonging to class A, B, C, D and E? So for that we have to understand this concept. If we have any IP address that contains binary number and first bit is 0 here, 0 bit is fixed and then number of binary numbers are changed, then we can say that it is belonging to class A because first bit is 0 here and it is fixed. Okay, next one is class B. So if I am talking about class B, then first 2 bits are fixed. First bit is 1, second bit is 0. If first 2 bits of my first octets are fixed of 1 and 0, then I can say that it is belonging to class B. Now we are moving to the class C. So first 3 bits of first octets are 1, 1, 0. So if any IP address is having first 3 bit patent 1, 1, 0, then we can say that it is belonging to class C. The same for class D. If we are identifying class C, then we have to check that first 4 bits are belonging to 1, 1, 1, 0 and next bit can be variable. And for the class E, we can see that first 4 bits are fixed and that is 1, 1, 1. So let's understand this concept with the help of one example. So if any particular scenario is given and saying that this is my IP address in binary, so how can I know this IP is belonging to which class? So we discussed about that. We have to check number of bits from the first octet. Okay, my first patent is 0 and that is fixed here. So that's why we can say that this particular IP is belonging to class A. Let's understand second example. Here from the first octet, my patent is, we can see that it is 110. So we can easily say that it is belonging to class C. In class C, first 3 bits are fixed, that is 110, and remaining bits can be changed. Now next example. In next example, my first bit is 1, second bit is 0. So from that we can say that this is belonging to class B. Okay, first 2 octets, first 2 bits of first octets is fixed here 10, remaining 6 bits can be changed here. So it is belonging to class B. And the last example for that, our first 4 bits are 1 and that is fixed here. So we can say that it is belonging to which class? That is class E. Okay, so how can we identify using binary? But it is not given here. It is not a binary representation. It is a decimal representation. Then how can we understand, how can we exactly know the particular IP address's range? So for that we have to understand the range. Okay, for that we have to take class A range, that is 0 to 127, class B is 128 to 192. Like that we have to understand the range. So for example, we have 227.12.14.87. So it is belonging to which class? It is belonging to class D. Okay, because it is the range between 1224 to 239. So for that we have to understand the range of class A, B, C, D, E and E in the decimal portion. Suppose we have IP address 193. So from the range we can easily know 193 is between 192 and 223. So we can say that it is belonging to class C. The same way, this is my range 14.23.120.8. So easily I can say that it is from 0 to 127. Okay, so we can say that it is from belonging to class A. And the last example is about 252 range. So first octet is saying that it is a decimal 252. So it is in between. We can say that it is from the last section of is all about class number E. So this is the basic idea. How can we identify our IP range from given particular scene? But this is all about classful addressing. In classful addressing, all the specifications are given in the box. Class A belonging to this pattern, class B belonging to this pattern. But when we are talking about classless, we cannot judge that. So in classful addressing, any user can easily identify how can we identify the particular IP addresses. Now, this is the example how the particular devices are assigned IP to the network. Okay, so we know already that IP address is 32-bit identifier for our host. So each and every network having some interface. Using that interface device, our request is come in and come out. So here, for given example, when different routers are available for incoming and outgoing request of the data. So that particular interface having specific link and IP addresses. So using that, we can identify the network here. So each and every device hosts are the part of the network. So they can easily identify. So we can say that that is the host. But how can we understand or explain the network scenario? That is the help of the particular interface. That interface is defined by our router. So that is the particular scenario. How can we understand the network address? Now we are moving to the specific addressing techniques. First is two-level addressing. So in two-level addressing, we have two options. How can we identify the particular network? So for that, we have to understand network address and network mask. So network address is all about network. It is all about the identifier of the network. From where, how can we identify the network? That is our network address. But when we are talking about network mask, so in background, how the router is identified that is the network mask. So here the router is used to extract the network address from the destination address. When we are talking about destination address of IP, then it contains network portion and host portion. So router is extracting the network portion. That the mechanism is known as a network mask. So how can we calculate and what are the different masks used by this particular network devices? So when we are talking about class A, so class A is particular range of network mask is 255.0.0.0. So we already know class A is used first octet for network and remaining 3 bits for host. So the network mask is exactly doing the same task. First octets are used by particular class A range for network mask. So all bits are 1 here. That's why our default network mask for class A is 255.0.0.0. Now next is class B. So we already know class B having first 2 octet for network and remaining 2 octet for our particular host. That's why we can say that in first 2 octets all bits are 1 as a binary representation. So all bits are 1, then our decimal represent will be 255. So that's why we can say that for class B, our default mask will be 255.255.0.0. And for class C, we know first 3 octets are used for network and 4th octet for our host. That's why our default mask is 255.255.255.0. So when we are talking about masking the extract the particular network address. So let's understand with this one example. So a router receives a packet with destination address 201.24.67.32. This is the destination address. Now, according to that, we can say that this is the network address. And how can the router is extracting the network mask here? So for that, they have to perform one AND operation. So from this particular IP address, I can easily say that it is belonging to particular class. Okay, so here 201.24.67.32. Now, my default mask will be 255.255.0.0. So from that it will perform the particular binary operation and find the particular network address, that is 201.24.0.0. So this is the exactly operation performed by the particular router at the network level to identifying the mask. Now we are moving to the next topic, that is a three-level addressing. So when we are talking about three-level addressing, it contains the extra portion, that is subnet mask. So first two portions are already covering two-level addressing, but when we are talking about subnet mask, then it use when we divide a network into the several subnetwork. Okay, just before that in two-level addressing we just consider that our one network is identified by the particular router, but when we are dividing this network into the subnetwork, small network, then how can we perform this type of extraction? Okay, in two-level addressing we are extracting the particular network address, whole network address, but when we are talking about subnetwork in one network, then the task will be more complex. So how can we do that? That is the use of three-level addressing. In that we are use the concept of subnet mask. So subnet mask is need to create when we are using the concept of subnetworking. So now let's understand this particular scenario. Our particular organization is divided into the four subnetwork. Our specific range is fixed here 141.14. But after that we can see that this network is divided into the four different subnetworks. So we can say that according to that our last two particular octets are sent in four subnetworks. Now if any request is coming through this particular router, then how can we identify the particular packet is belonging to which subnetwork? For that we have to understand this particular concept. Okay, now exactly how the subnet is performing here. So for performing subnetting we have to understand the concept of borrowing. So for example, let's understand this is the scenario in that our network ID and particular host ID is available. Suppose if I want to perform subnetting, then network is taken some bits as a borrow from the host ID. Simple concept is there, we have to take some bits from particular host as a borrow. For example, if I am taking the example of class B, my IP is belonging to class B here, and class B is performing the subnetting concept. So first 16 bits are used as a network and remaining 16s are used for host here. But if I want to take a IP address as a subnetting, and if I want to use next 2 bits for my subnetting task, then my network is take 2 bits from my host ID. So my next 17 and 18 number of bits by our network here, and remaining bits of the particular host will be used to identify the host. Let's understand this scenario with the help of this particular example. So when we are talking about this particular 192.168.1.0 and /27 here. So /27 is all about saying how many bits we are taking from our host ID. So here 3 bits are extra here, because when we are talking about class C here, then 24 bits are used for network address, and here total prefix are 27, so it is more than 24, and extra bits are here 3. So that's why we can say that this is the concept of subnetting here. So how many number of bits we are taking here? Total 3 bits are given. So from that 3 bits, how many networks I can create here? So it is using 2:n concept. So here extra 3 bits are taken as a borrow. So we can create 2⁵ 8 network from our subnetting concept here. And for that our default mask will be 255.255.255.0. That is my default mask address of subnet of class C. So this is the example how exactly we are taking some bits from our host ID and assign to the network. Now, how can we calculate that? So for that we have to first calculate the total subnet at the formula of 2 raised to n. And the second step we have to decide the block size here. So block size will be telling that how the exact the range after creation of subnet, what will be the range of our particular IP addresses, that will be our second step. So total process of our subnetting is divided into the two parts. First is creating subnet using 2 raised to n concept, and the second one is to assign the block size. Now we are moving to this example. Our subnet is given 141.14.1.120/18 here. So this is the example basic belonging to class B. Here our prefix is 18 here. So for class B, our first two octets are for network and remaining for host. So first two octets having 16 bits, yes. So what are the exactly new bits are available? 2 bits, from 16, 17 and 18. So 2 bits are borrowed from our particular host. So total number of subnet can be created is here 4. Now what are the exact subnet mask here? If we are talking about subnet, default subnet mask of our class B, then it is 255.255.0.0. But already we are taking 2 bits from our particular host, then our default subnet mask cannot be used here because 2 bits are changed here. Then we have to particular calculate the subnet mask. And the last we have to calculate the block size. Using that our range will be decided. So this is the example how can we calculate the subnet mask. So here address will be given 141.14.120.77. And here mask will be 255.255.192.0. So from that we can calculate the block size here. So block size, if we are performing here AND operation, in AND operation we can say that our resultant will be number 1, then both the numbers are 1, otherwise it can be considered as a 0. So from that we can identify that 141.14.64.0 is our particular subnet address, and we can say that 64 is our block size. So this is the basic concept of 3-level addressing. Now in this concept, in examination, very important questions are how can we find the number of hosts here. Okay, so for the finding number of hosts, we have to use formula 2 raised to h here. So h is the number of host bits. For example, we have 141.14.120.77. This is my given IP address and prefix is 18. So if we are talking about a number of host years, so our according to this prefix 2 bits are given to the network for subnetting concept. So remaining bits will be used for the host. So we have here 24 minus 18 here. So 24 minus 18 is all about 6. So total 2 raised to 6 would be our number of hosts for our subnetting. So this is the about how we can calculate number of hosts here. Now we are moving to the basic subnetting concept. That is all about higher order bits that contains our network address, and lower bits it's all about particular host bits that will be given in this particular figure. So this is the basic idea how the subnetting is dividing our particular network into the subnetwork. Now finally we are moving to the types of the IPv4 network. So how many types of address will be there? So basically we already discussed network address, that is identified to our network. We already discussed the host address, that is assigned to each and every n devices. And one more address is there, that is the broadcasting address. So broadcasting address will be used by different protocol for the different purpose. We already discussed ARP protocol and data link layer. So this type of address is used for the special purposes. So basic 3 types of addresses are available: network address, broadcast address and host address. Now we are going to the second addressing method, that is a classless addressing method. So when we are talking about classless addressing system, then it is very improving addressing system. We are not fixedly assigning any classes here. When we are assigning class to the particular range, then number of bits are waste here. Suppose I need 100 IP addresses and I have used class C, then more than remaining bits of 100 are wasted here. So that's why we are using the classless inter-domain routing mechanism. That is all about CIDR or classless addressing. So when we are talking about classless addressing, then we doesn't bother about what is the particular number of bits here. According to that scenario, we are dividing this particular data items or IP range to this particular block. So CIDR dynamically assign the block of IP addresses. So we are not specifying that first block for network, remaining block for host. It assigns dynamically according to the need. But it is mandatory that it is specifically assigned by our network administrator according to the requirement of the organization. But when we are talking about how the exactly specification of our CIDR, so CIDR notation is about 4 octets are there, and after that prefix is available. When we are talking about classful IP addressing, then prefix is not compulsory. When we are using CIDR notation, at that time we need here prefix. This is the example 182.0.1.2/28. But 182 we cannot say that it is belonging to class B. But when we are talking about class full IP address, then we know that the range 128 to 191 is belonging to class B. But here in classless IP address, we cannot say that because network administrator will assign this type of IP address to any class. It will use the specific prefix here for the purposes dividing our IP addressing for this purpose. So this is the basic how CIDR is working in your syllabus. So thank you very much for watching this video. We explained briefly how the IP address is working here.